Hey, it's Mr. Kabbalah. This is a statistics lesson on Unit 8, Section 2, the T distribution. Let me know if you have any questions, and hope to see you soon. Enjoy!
It's going to go over the T distribution. Here's a little history. In 1908, the guy named W.S. Gossett, who was working for Guinness Brewing Company, yes, that Guinness Brewing Company, um, he developed this method of estimating a population mean when we don't know the population standard deviation, which is actually going to be the case. It's going to be the case most of the time. So he actually published it under the pseudonym Student because his company wouldn't let him publish any of his works. So it starts with this equation, which says that assume that x has a normal distribution with mean mu, which is unknown, for sample sizes of size n with a sample mean of x bar, and sample standard deviation s. The t variable is given by all of this. And here's a picture of the guy, W.S. Gossett. He's the one who came up with it. So when we use the t distribution, we will assume that the x distribution is normal. Which means that if you were to make a histogram of the data, it would be symmetric about the mean and mound-shaped, approximately so. Now, the t distribution has what's called degrees of freedom. Which people abbreviate by DF. And the degrees of freedom are it's the sample size minus 1. And what this does, the degrees of freedom, they affect the shape of the distribution, the t distribution. So the t distribution shape depends on the degrees of freedom used. The graph of the t distribution is symmetrical about the mean mu equals 0. The main difference between the t distribution and the standard z distribution is that the t distribution has larger areas under the tail, so at the far left and the far right. As the degrees of freedom increase, the t distribution approaches the standard normal distribution. So as a little visual, here is, let's say, the standard normal curve. So let the black line standard normal. All right, and again, it's centered. Let me make that a better line. It's centered above mu, which if its standard is 0. Now, with the t distribution in red, let's say that we have a degree of freedom of, let's just say 3. It would look something like this. So it's still mounted the highest above the mean, but you can see that the tails at the left, excuse me, and the right are a bit wide, like there's more area underneath them. Sorry. Let's say we increase the degrees of freedom to, again, let's say 8. What's going to happen is that it's going to more closely resemble the standard normal curve, something like that. It's not perfect, but basically as you increase the degrees of freedom, or basically the more, the larger your sample size, the more it's going to resemble the standard normal. So we can also calculate confidence intervals for students' t distribution. The critical value in this distribution is t sub c, or tc, and the margin of error is given by the equation that you see. E equals the critical value of the t distribution times the sample standard deviation s divided by the square root of the sample size. Now, I believe for Unit 8, Section 1, I showed there was a supplemental showing you how to do this on a calculator. Same thing can be done with the t-distribution, which I'll show you. So even though we can calculate this by hand, we're going to let the calculator do a lot of the work for us. So just jumping right into an example, suppose an archaeologist discovers only 7 fossil skeletons from a previously unknown species of miniature horse, like Little Sebastian on Parks and Rec. Reconstructions of the skeletons of these 7 miniature horses show the shoulder heights in centimeters to be, and you see them there. To construct a 99% interval for mu, the mean shoulder height of the entire population of horses, I'm going to use my calculator. So in order to do this, we need a sample mean, we need a sample standard deviation, and again, we're looking for a 99% confidence level. So what I would do, I would go to Stat, Edit. Now I've already inputted all of the heights of the miniature horse fossils, so there are 7 of them. All right, I'm going to go back to Stat, Calc, and if I just want the sample mean and the sample standard deviation, I'm going to do one variable statistics, so one var stats, and it's going to give us a mean of about 46.14. So let's write that down, 46.14, and a sample standard deviation of, that's going to be this one, the 1.19. Right, and again, going back to the calculator, I'm going to let it do most of the work. So if I want to do a t interval, I'm going to go to Stat, I'm going to go to Tests, and t interval is choice number 8. So what do we're going to keep it on stats. So the x bar is that 46.14. The standard deviation of the sample is 1.19. Now I have all of the decimals in. You don't have to type them all in. So if you didn't type, or if you only used 46.14 and 1.19, you might get slightly different numbers than I'm going to get. Now I believe the interval we wanted, the sea level, was 99%. Let me double check that that's right. Yep, 99%. And change that to 0.99 and then calculate. It does its thing. And right up here, it tells us the interval, 44 point, let's say 48. So 44.48 centimeters to 47.81 centimeters. And what this tells us is that we can be 99% sure that the true population mean is between those two values. So that's on the calculator. The rest I'm going to show on Google Sheets. You can do these also on your calculator. You can do part on the Google Sheet, you can do, and then the rest on your calculator, depending on your comfort level. I'm going to do these on Google Sheets. So as an exercise, the company has a new process for manufacturing large artificial sapphires. In a trial run, 37 sapphires are produced. Use Google Sheets to create a 95% confidence interval. So if you open up, what just happened? Okay. I don't know why this 2 is here. Maybe it'll go away. In any case, I can work around it. All right, so if you open up the Google Sheet, I have the weight and carats here. We need to find first the sample mean, so equals average, and we're going to do all of these. I don't know what this is. All right, I'm going to get the sample standard deviation, so STDEV. Now, don't choose one that's for the entire population. You can choose this first one, even this one that has .s. All right, now there's a function on Google Sheets called confidence. You could actually do a confidence interval for the normal distribution, but if you start typing confidence, you can also see there's one confidence.t, and that's the one we want. All right, so the alpha that they have here, that's the confidence level that you want. Now we want, I believe it was it 95%? Yeah, 95%. Now the thing you'd have to know on your Google Sheet is that it won't do the 90. You have to do 1 minus your confidence level. So if we want 95% or 0.95, then this alpha would be 0.05. They actually kind of tell you that down here. They give you kind of nice little example. For example, all right, so 0.05 for 95%. Standard deviation I'm going to set at B3. And then the size is the sample size. So the sample size, it said 37, so 37 artificial sapphires. Now what this gives you is actually the E, right? So this is the amount or the margin of error. So on Google Sheets, we actually have to set it to subtract off of the mean and add on to the mean. So I'm going to do the mean minus what I just calculated, the error. And then I'm in my next cell going to do equals the mean plus the error. So we can be 95% sure that between 6.49 carats and 6.75 carats, I rounded there, 6.49, so 6.49 to 6. Did I say 75? 75 contains the actual population mean. All right, so let's do another. Oh, okay, here's this. When should you use either the ZC or TC? If you know the population standard deviation, sigma, then you should use ZC. But that rarely happens. Most of the time, if you're not going to know the population standard deviation, then this is where you use the T distribution. So you actually use this more often. So the next example, now what I'll do is basically go through these and get an answer. I'm going to maybe speed up the video so you don't have to watch every single keystroke, and just kind of double check that you get the same answers I do. Again, depending on rounding, you might get something different, but here's the sleeping bag exercise. right, so right here, I'm going to just show you, I'm going to use the calculator now. So I have the sample mean, the sample standard deviation. I did that on Google Sheets. So what I'm going to do is do the rest on the calculator. I hit stat over to tests number 8. All right, the sample mean was 9.95. Standard deviation was 1.02. I believe there were 10 tests, and we want a 99% interval. So 8.9 to, let's say, 11. 8.9 to 11. Right, based on your confidence interval, do you think the patient still has a calcium deficiency? If you go back in the problem, it talks about a calcium deficiency is below 6 milligrams per deciliter. So what I would say is no, because we can be 99% sure or confident that this patient's level is between 8.9 and 11 milligrams per deciliter, which is less, or I'm sorry, which is more than 6. Okay, so there's a little bit of use with the Google Sheets and your calculator on t-distribution and confidence intervals in a t-distribution. So let me know if you have any questions. I can go over things if you need to, and hopefully everything's all right. Hopefully we'll see you soon.